permutation and combination, chapter 11. Now, before we talk about permutation, what it's all about, yeah, you need to understand the idea of multiplication and similar. So, for example, okay, let's talk about drawing something from a box. Let's say you have a box with the cards, number cards, letter cards. Let's say the letters are A, B, C, D. Let's just say A, B, C, D. You have 4 cards, okay? And then you have another box here with 5 number cards, okay? So I'm going to draw one item from here and one item from here. And you can see that if, let's say the first box is the letter, the second one is a number. So we want to see how many possible matchup we can have. Now you probably have done this in your lower form, alright, some of you. So letter cards, I have 4. So it's A, B, C, and D. Number cards, you have 5. So it's 1, 2, 3, 4, 5. So if you were to match the letter cards and number cards, this would be what? A can match with 1, 2, 3, 4, 5. So you can think this way. Now, you may want to write in sample space like this: A1, A2, A3, A4, and probability will do all this. Now, but for now, I just list for you. So you get the idea: B1, B2, and so on. C1, C2, comma here, and so on. D1 and E1, and total you have 4 items to match with 5 items here. So the number of ways we can match is the number of options that you have here, which is 4, the number of options that you have here, which is 5. So it's a 4 by 5, answer is 20. Right, so we call this a multiplication principle. Now basically, if you have R option to choose from the first sample, if you like, and S option to choose from the second sample, the number of ways we can match them up or pair them up is R times S. Yeah. Now this is not limited to only choosing number cards, letter cards, and all that. We can talk about, let's say, when choose people. All right. So let's say I want to choose. Can I use 5 people? Albert, Brandon, C for Calvin, D for David, E for it. Okay, can I not use? Okay, I use 5 people, Ethan, and 5 boys. I'll match up with how many girls? Let's say 3 girls. The girls are P for Paula, Q for Vinny, R for Serena, and yeah. So how many ways can we match up? Now we have 5 here and 3 here. So this is one combination. This is 2 combination. The 2 ways of second way of matching that. This is 3. This is 4. This is 5. So basically we have 5 ways to match up with the 3, right? So my total number of possible matchup will be 15. Okay. So number of ways the badminton mixed double team can be formed, yeah, from the group of 6 boys and 3 girls. Okay, so remember I have 6 boys. I will match up with 3 different girls. Answer is 18. The number of ways will be 6 by 2. A coin you can have head or tail. Total. Before we proceed to the next example, let's talk about permutation. What is permutation? Permutation is a way of a number of arrangement to arrange an order in object, set of object in a certain order. So now, if you want to arrange an object in a certain order, remember this time the number of the object that we have, we cannot repeat them. For example, we talk about A, B, C, D, E again. Let's say I just give you, okay, simple example is 5 letters. I want to arrange in a row, and I want to arrange all of them, 1, 2, 3, 4, 5. Okay, now if I want to arrange all of them, the first one, I have 5 options to choose from. I can choose any one of them. So let's say I choose C. So number 1, I got 5 options here right now. So if I've chosen C, I put C here. Can I choose C again? No. So now I have how many options left? I have 4 options. I can choose any one of them. Let's say I choose A. Now if I put A here, can I choose any other letter after that? No, I only have B, C, D to choose from, like 3 options here. So let's say I choose D, so I put D here. Now I'm left with 2, I can only choose B or E, so 2 here. Alright, so let's say I put E here, and lastly I have no choice but to put B here, so only one option. So the number of ways to arrange them in a row is 5 by 4 by 3 by 2 by 1. We call this 5 factorial. Okay, now this is not I mean, many years ago, this boy who shout at me, yell at me and say the answer is 5, yeah? Because this is not 5 because it's exclamation mark, but there's an exclamation mark here in your calculator. Can you see? 120, yeah? So the meaning of this exclamation mark means the number, the integer, multiplied itself in descending order up to 1. So if I give you 3 factorial means what? 3 by 2 by 1. If I give you 2 factorial means 2 by 1. And 1 factorial is actually 1. Now it's an interesting question. Huh? How about 0 factorial? Now 0 factorial is also 1. I know this one sounds a bit confusing because when we say 5 factorial means what? The number of ways to arrange 5 items in a row. 3 factorial means the number of ways to arrange 3 items in a row. If you have 0 factorial means you have no item to be arranged. Let's consider one way. I know it sounds a bit weird, right? It sounds a bit confusing, but when you have no option to arrange, yeah, it's also one way by itself. It's like I ask you, what do you eat? You nasi lemak roti canai, or char kway teow. I don't eat anything. Not eating anything, not arranging anything is also an option. Okay, now one more thing. If let's say I give you 5 numbers, okay, let's just make 4 items, 4 numbers. I just give you something to compare. So let's say we want to use 4 numbers. Let's say my favorite number 5, 7. What do you like? 8, because Chinese. Or some people like 3. So now, if I want to arrange 4 numbers in a row, okay, I want you to compare this. The first case is with repetition. With repetition means I can use back the same number again. So how many ways can you arrange this now? 4. I can choose any one of them. But let's say I put number 5 here. Now the second box, I can still choose back the same number, so it's still 4. The next one is still 4. Because again, I can repeat. I can have 5, 5, 5, 5. I can have 7, 7, 7, 7. So the number of ways to arrange these 4 numbers in a row is actually 4 by 4 by 4 by 4. Now this is not in reducing order. What is 4 by 4 by 4? 2, 5, 6, right? So if it's with repetition, then the factorial method doesn't apply. But if it's without repetition, that means that when I choose number, let's say, go back to this again, 5, 7, 8, 3. If I choose, I have 4 options here. If I choose number 7 and put it here, I cannot choose 7 here again. I have to reduce by 1 because I can only choose 5, 8, or 3. Right? Let's say I put number 3 here. I cannot put 3 again over here. So I can only choose 5 or 8. So there are 2 ways. Right? Let's say I put number 5 into here. I cannot choose number 5 here again. I can only choose 8, only one way. Right? So the number of ways to arrange them are 4 by 3 by 2 by 1. Or 4 factorial. We can write this as 4 factorial is 24. We can use a calculator. Remember, it's over here, 24 shift factorial. There you go. Oh, sorry. 4 factorial, 24. Alright? Okay? How many ways can we arrange the letters of the word factors? Factors has how many? 7, right? So you can choose to list out 4, 5, 6, 7. And write down, okay, so I can start with any of the letter, 7 ways, reduce by 1, 6, 5, 4, 3, 2, 1. So the number of ways is just 7 factorial. Now use your calculator. 7 factorial is 5040. Yeah? 5040. Okay, 9 digit. How many ways you can arrange 9 digit? 9 factorial. That will be 9, 3, 6, 2, 8, 8, 0. It's very long. It's possible. Sorry. It's on the shelf. Answer? 6 factorial. Answer? Anybody? 6 factorial? 720. Okay, come 7 times 3. How many ways you can arrange them? 8 teams, 8 factorial, answer? Say again? 3 to 0. Okay, simple. So how about permutation of R item chosen from N item? Okay, so R item chosen from N item. Meaning, for example, okay, the classic example I'd like to give you is that, let's say I have 8 people in a row, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, in a 100-meter race. If you have 100-meter race, right? So I have 8 people in a starting block of a 100-meter race and final. So now my question is, how many ways can I choose the gold, silver, and bronze medalist? Yeah. Okay, the first person will get gold, right? Second will get. Can I write here? Gold, silver, bronze. The fourth person will get what? Nothing, plastic. So I only want the first 3. The rest I do not want. Now, normal situation, if you have 8 people in a row and I want to arrange them, this will be what? 8 option here, 7, and 6, right? So, but I continue to be 5, 4, 3, 2, 1. But in this case, I'm not interested in the rest. I'm only concerned about the arrangement of the first 3. So you can think this way. Number 1, you can think is A factorial. Then I need to cancel out the rest of it, so I divide by 5 factorial. Now, you can actually think 8, 7, 6 straight away. Now, what I want to do is I want to show you how we use the formula, because it works like this. 5 factorial is actually the 5 people left from the remaining. So I have 8 people to choose from, initially, but I need to subtract 3 people. Why? Because these 3 I'm choosing them, right? So the remainder will be left is 5. Now we know 8 factorial divided by 5 factorial. By the way, let me clarify this. 8 factorial divided by 5 factorial is 8, 7, 6, 5, 4, 3, 2, 1. And what is 5 factorial? It's 5, 4, 3, 2, 1. As I cancel them, I'm left with 8, 7, 6. Yeah? 8 by 7 by 6. You can type 8, 7, 6, 3, 3, 6. So, okay. Now, this notation can also be written as this A, B, 3. The symbol B, the letter B means permuting. So that means to arrange. Out of 8, I'm only arranging 3. And you can find this in your calculator. 8 shift multiply 3. See, you get the same thing. 3, 3, 6. Right. Now, we can go on with other arrangement. Just so you know, 8B1, if you use a calculator, it's just 8. 8B2 means 8 times 7 in descending order, because I'm only arranging 2. 8B3, 8, 7, 6. 8B4, 8, 7, 6, and 5. By the way, how about 8B8? 8B8 means out of 8, I arrange all of them is going to be 8 factorial. This is the same as earlier, the concept of factorial. Okay, so anything else? That's all right. So you just use a calculator actually. For all these, you just can just type in 8B here, 8B5. Did you see? 8B3, 8B6, or 9B4. You can just type in the calculator. Calculator can do the work for you, right? Okay. Remember, in the difference between this and the earlier one is that now I don't want to choose everybody. I only want to choose a certain number from the total. So out of, for example, out of 8, I only want to choose 3. So you can just, you're left with 5, so you cancel each other, you get 8B3. So you don't have to count manually like this, you just use your calculator, type in calculator and get the answer. Okay? I have a 4-digit number, okay, that I want to form from this 1, 2, 3, 4, 5, 6. So we can write number of ways to arrange them is 6 arrange 4. Okay, somebody 6 arrange 4, 6 B4, 360. Now another way of thinking is this, that we can draw 4 boxes. The first one you have how many options? 6. Second one you have 5, 4, and 3. So we can take 6 by 5 by 4 by 3. You still get 360. Universal. Come on, how many letters? Can you count? 2, 4, 6, 8, 9. 9 arrange 5. Somebody. President, Vice President, Secretary and Treasurer. So how many different ways we can select the candidate? So you can think the first person becomes President, second becomes Vice President, third Secretary, last is the Treasurer. So if the first person, how many options do I have? 8, right? I can choose any one of the 8, am I right? Second one, how many? 7, 6 and 5. Yeah. So you can multiply together, or you can say 8p4. Somebody. 1680. Yeah. Okay, so I got 10 contestants from how many countries? Oh, they never say how many countries. So I want to give gold, silver, medal. So answer is 8p3. What is 8p3? 720. Let's look at the next one. Now, here we have condition. When you have condition, you need to fulfill the condition first. Alright, so we have a 6-digit number. So we draw 1, 2, 3, 4, 5, 6. With the condition that it cannot begin with 0. If you cannot start with 0, we can start with what? 1, 3, 5, 7, 9. Everybody? 1, 3, 5, 7, 9. Yeah, I cannot start with 0. So how many options? 5. Okay, how about this one? Remember I have 6 digits. I can only choose from this 6 digit. I've taken one number out, I'm left with how many? 5. I can still choose other digit including 0 from the second digit. The first one cannot be 0. Second one can be 0, so it's 5. Then the rest will be what? 4, 3, 2, 1. So the number of ways is 5 by 5 factorial. Somebody? 600? Is that correct? Let me draw 4 boxes. 1, 2, 3, 4. Less than 7,000, 2, 3, 5. There are 3 ways. But remember, if I put one number here, I'm left with 3 more. Put another number in, 2 and 1. So the number of ways is 3 by, you can write this as 3 factorial. Is it 18? Yeah. Between 10,000 and 50,000. So I draw 1, 2, 3, 4, 5. If it's between 10,000 and 50,000, can I start with 1? Yes. Yeah, if I start with 1, for example, 1, 0, 2, 4, 5, I still get more than 10,000, right? How about 4? Can I start with 5? Answer no, because if I start with 5, it will be more than 50,000. Between 10,000 and 50,000 must be 1, 2, 4. Okay. Anyone? The first digit? How many options? 3. Remember, I got 5 digits to start with. I've taken 1 out, I'm left with 4. I take 1 more out, I'm left with 3. Take 1 more out, left with 2. Lastly, 1. So the number of ways will be 3 by 4 factorial. Somebody? 72. Okay, B. How many of these 5-digit number are divisible by 5? That means that now we got another condition. We have 2 conditions. The first thing is we have to start with 1, 2, 4. And the second, how many ways here? So the number of ways will be 3 by, right? Right one. So we have a 6-digit number. We have to form from this given 6-digit such that the last digit must be even. Even means 2 and 4. So there are 2 here. I've taken 1 out, left with 5, 4, 3, 2, 1. Yeah. So the number is 5 factorial times 2, 240. Now, how many of the 6 digits are greater than 500,000? If it's greater than 500,000, means 5, 7, 9. Okay, even means 2 and 4. So I have 2 ways here. How many ways here? 3. This will be what? 4, 3, 2, 1. So the number of ways will be 3 by 4 factorial by 2. Answer 24 by 6. 145. Yeah. Okay, next. Find a number of 4-digit number. 5-digit number. 1, 2, 3, 4, 5. You must be odd number. Odd number means 1, 3, 5. Okay, so there are 3 here. 4, 3, 2, 1. So we can write 4 factorial times 3. 24 times 3, 72. B, 1, 2, 3, 4, 5. It must be less than 60,000 means 1, 3, 5. Then 1, 3, 5. Now notice, say if I start from here, start counting from here, I have 3 options. This one I have to reduce by 1. Because, for example, you put number 5 here, I cannot put number 5 here anymore. You reduce by 1 number 2, then the rest will be 3, 2, 1. So the number of ways will be 3 by 3 factorial times 2. You can write 3p2. Some people write 3p2 for this 2. That will be 36. Okay. So, a 6-digit number are to be formed using this digit. Each digit may only be used once. Right? How many different 6-digit odd number can be formed? 3 and 7. The rest I would, because I've, so you can write 5 factorial times 2, answer 240. Okay, no problem, first part. Now, second part is a bit more challenging. Why? Now, look at this this way. I draw 6 boxes. It must be, how many of these 6 digits are odd and are less than 600,000? So there are 2 conditions I need to fulfill. Number 1, it still has to be odd number, so it's 3 and 7. Number 2, it must be less than 600,000. In order for it to be less than 600,000, you must start with 2, 3, 4. Can I start with 6? No. So it's 2, 3, 4. Now here's the thing. You notice that in example number 7, the option that I have here and the option I have here, they are different. So I got 3 options here, there are 2 options here, because whatever I choose here does not affect the number of options that I have here. So we can just write 3 and 2. Like this one, there are 3 digits. See, the digits are all different. There are 3, there are 2. But if the claim, look at this, they're the same, right? They're the same, right? So whatever number I chose here, it will reduce the number of options by 1. Same here. The numbers are the same, right? 135, 135. Whatever I chose here, reduce the option by 1. This one, look at this. If I choose 3, it will reduce the option by 1. If I choose 2 or 4, it doesn't affect the option. So if that's the case, we have to break it up into 2 cases. Case number 1, I start with 3. Case number 2, I start with 2 or 4. Yeah, if I've chosen a certain number, it will reduce the option, and if I don't choose that number, it doesn't reduce the number of options. You have to break it up to 2 cases. Right? Case number 1, case number 2. Okay, for case number 1, 1, 2, 3, 4, 5, 6. I start with 3. This is 3 and 7. How many options do I have here? Guys, how many options? 1. How many options do I have here? Still 1. Because once I've taken number 3 out, I cannot put 3 here. I only have 1 option. That is to choose number 7. The rest will be what? 4, 3, 2, 1. So you can write the number of ways 1 by 4 factorial by 1, which is 24. Case number 2, 1, 2, 3, 4, 5, 6. I must start with 2 or 4. I must end with 3 or 7. There are 2 ways here, 2 ways here, 4, 3, 2, 1. You can write 2 times 4 factorial times 2. 24, 96. So number of ways will be 24 plus 96, 110. Is that correct? Yeah, 96. Okay, come hurry up, finish. So I guess 36 answer. Let's see. Okay, so the first one, you want 5-digit number. So I draw 1, 2, 3, 4, 5. It cannot begin with 0, so we have to choose what? 2, 3, 5, 6. So there are 4 here. 4, 3, 2, 1. So number of ways 4 by 4 factorial. Somebody? 24, 96, right? Okay. B. How many of these 5-digit number are even? So you have two conditions now. You want it to be cannot start with 0, 2, 3, 5, 6. At the same time, it must be even. Even means 2 and can it be 0? Can it? 0 to 6. 0 is even number, ends with 0 is also an even number. So here we have to take two cases. Now case number 1. Now imagine if I start with 2 or 6, it will reduce the answer by 1. If I start with 2 and 6, 2, 3, 4, 5, this is 0 to 6. Okay, case number 2. Okay, it will be 3 and 5. 1. Okay, sorry, I don't want to write so many steps. I'll just show you right this. This one will be 0 to 6. Now take note. If I start with 2 or 6, there are two ways. But this is how many ways? 2, not 3. Because let's say I put number 6 here, I cannot choose 6 anymore. So there will be 3 to 1. Number of ways will be 2 by 3 factorial by 2, which is 24, right? Okay. Now case number 2. By the way, how many ways here? 2. This one will be 3. It's not affected by whatever number that I chose here. Yeah. So 2, 3, 3, 2, 1. Number of ways 2 by 3 factorial by 3. 6, 6, 36. Oh, you haven't added up. None of you got this right. Oh, so sad. You all got 36, but you forgot to add the 24. So when you add up 24, you get 60. You got what, Jenna? Oh, you only 60. Okay, sorry, I didn't hear. How many ways we can write? Arrange 7 letters in the word Belgium. B does not occur in the first letter. So let's put 1, 2, 3, 4, 5, 6, 7. You don't want B. No B. No B means you have to choose what? Can I put a non-B? I still have how many? Hello? I still have 6, right? I can choose B. I can choose E, L, G, R, U, M. Okay. Now, the rest will be what? 6 to 1. Or we can write 6 factorial. Somebody, what is that? 4? 4 what? 4, 3, 2, 0. Okay, the next one. The vowels must be arranged next to each other. Okay, this is something new. The vowels must be arranged next to each other. How many vowels do you have here? 3, which is E, I, U. Vowels means E, I, U. When they say the vowels must be arranged to each other, there is a particular technique that you need to know. Number 1, I tie them together in a box. E, I, U is a box. Tie together. Okay? Now, how many ways can I arrange E, I, U next to each other? 3 factorial, 3 to 1, right? Yes? I tie them to each other. Okay, I still have consonant. The consonants are L, G, M. Right? So I'm going to put 1, 2, 3, 4. Now, if I tie them together as a block, this is considered one block. And I have how many blocks in total? How many blocks in total? This is one, huh? Wherever E goes, I and U must follow. Okay, you get the pun? No? So, wherever E goes, I and U. Okay, fine, never mind. So I have how many blocks now? I have 5 blocks, right? So how many ways can I put 5 blocks in a row? Tell me. How many ways can I put 5 blocks in a row? 5, 4, 3, 2, 1. Remember, this one they can be, B can be placed in front, L can be placed in front. There are so many ways to arrange them. So we have to put 3 factorial ways to arrange the vowels, multiplied by 4 factorial, arrange the rest. That will give us what? Somebody? 120, 720. Okay, now I just want to highlight this because some people say, Terry, what if I do like this? EIU together. Then, oops. Can you see EIU together? And then I put 1, 2, 3, 4 to arrange the rest. If I put 3 factorial times 4 factorial, can or not? Cannot. But we can. Yeah, with 3 is considered as 1. We can slot this in. We can slot this in between here. We can put it in between here. we can put it in between here. Now I know some people will say, Terry, what if I do like that? I put 3 factorial to arrange the vowels, 4 factorial to arrange the consonant, and I can see there are 1, 2, 3, 4, 5 different arrangements, so I times 5. Now guess what? This is the same, isn't it? Do you know that 5 times 4? Yeah? But I don't like to do this. Maybe I want to draw the 5 different. Now I won't do that. I will consider this as a block, and knowing that I have 5 blocks, I know there are 5 factorial ways of arranging these 5 blocks. Can I? Yeah? Remember, whenever they say arrange them next to each other, we tie them together as a block, consider this as 1, and find number ways to arrange them. Okay? 5 factorial. Now, Jordan, it begins with letter J. Jordan has 6 letters, Jordan. So it begins with letter J. There's how many ways to put letter J here? 1. Now the rest, there's no condition. When there's no condition, how many ways to arrange them? 5, 4, 3, 2, 1. So we can write 1 times 5 factorial. Okay? Arrangements have the letter A at one end and letter O at the other end. Some of you forgot the times 2. That's why you cannot get the answer. Letter A at one end, letter O at the other end. So let's say I start with A, I end with O. True? Yeah? But I can also start with O and with A. So you go to times 2. Yeah? You go to times 2. Or some people, they write this. AO, AO. This. 2. How many ways here? 1. It reduces by 1. Okay? How about the remainder? How many more left? 4, 3, 2, 1. So you can write this as 2 times 4 factorial. Answer is 48. Yeah, notice some of you got 96, some of you got 24. Example number 11. 6 boys including Harry and Keane are seated in a row. Calculate a number of different ways this can be done if Harry and Keane sit next to each other. Alright, so how many ways Harry and Keane can sit next to each other? 2 factorial. You can write 2 times 1, you can write 2 factorial. Okay, now I have 6 boys. How many left? 1, 2, 3. You already got to understand the idea. The idea of people sitting next to each other. You tie them together is 2 factorial, yes? And how many blocks do I have now? This is 1 block. 2, 3, 4, 5. Yes, there are 5 blocks now. How many ways I can arrange these 5 blocks in a row? 5 factorial. Yes? And answer will be what? 204. Can or not? Are you with me, everyone? Yes? Now, next one. Harry and Keane have exactly 2 other boys sit between them. So, I will draw 4 boxes. Okay? You're going to put Harry here, Keane here. There are 2 more boys. Okay, now this one is a bit more tricky. You're going to put how many more? 2 more. Okay, how would you want to arrange it? There's so many ways to do it. Okay, now number 1, I think let's settle Harry and Keane. There are 2 times 1 factorial ways. It's similar to this one. It's similar to this one, right? 2 times 1, right? Yes? Now, the next thing is, how about these 2? What do you want to do? Do you want to arrange them first? Do you want to arrange them first? Okay, why 2 factorial? To put Harry and Keane next to each other. Now, I still have to choose 2 more here. The 2 person who sits between them. How many options do I have? 4 people. Then I choose or arrange particular. You can write 4 times 3. Yeah? You can write 4 times 3. Correct? This is a block of people. How many blocks do you have now? How many blocks? 3. This is 1 block. 2 and 3. Including the remaining 2 boys who are not seated. So this is what? How do you write this? How do you write this? Come on, tell me. 3. In fact, be what? 144? Yes? Why? Say again? Tell me, yeah? So, the first one. Now, when we say boys and girls are seated alternately, the word alternately means boys, girls, boys, girls, boys, girls, or girl, boys, girl, boys. Now, take note, if you have 4 girls and 4 boys, everyone, if you have 4 girls and 4 boys, then you can do like this. Let's say I have 4 girls, 4 boys, right? Then I can do girl, boy, girl, boy, girl, boy, girl, boy. True? True? Or boy, girl, boy, girl, boy, girl, boy, girl. True or not? That means I can start with a girl followed by boy, or I can start with boy followed by girl. But in this case, I only have 3 boys, but I have 4 girls. That means I cannot. Let's say I start with boy, girl, boy, girl, boy, girl. Then I ran out of boys. I have another girl. Here, right? Then it's no longer alternately. So in the event that boys are less than girls, you need to start with girls, followed by boys. Girls, boys, girls, boys, and a girl. Girls must be at the 2 ends. Okay? So how many ways to put the girls here? 4, 3, 2, 1. And I'm going to use another pen. How about the boys? The boys will be 1. So the number of ways to arrange the girls is 4 factorial. Right? The number of ways to arrange the boys are 3 factorial. That will give us 1, 4, 4. True or not? Okay, the boys sit together and the girls sit together. Now this one, you take note of. The boys how many? 3. Girls how many? 4. 1, 2, 3. So how many ways to put the boys together? 3 factorial. How many ways to put the girls together? 4 factorial. Now, as a block, how many blocks do I have now? 2. Some of you forgot to do it. So it's 3 factorial, 4 factorial. You can just write times 2. 2 factorial is the same as times 2. Answer please. 288. A pineapple is placed at each end. So here we need to put a pineapple at one end, another pineapple, another end. So let me say I draw out for you. How many fruits do you have? 9, right? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 2 pineapple. You need to put 1 pineapple here and 1 pineapple here. True? At each end. So how many ways to put a pineapple here? 2. Remember you have 2 pineapple. I have 2 options. So once I take 1 pineapple put here, how many ways do I have? 1. Okay, the remaining I have how many in between? 7. So how many ways to arrange the remaining 7? 7, 6, 5, 4, 3, 2, 1. So you don't have to write all these things. We can write 2 factorial ways to arrange the pineapple and 7 factorial ways to arrange the rest of the fruits. Is that right? Where is 5040? Remember what?
No, but then like times 2.
Why you times 2? 5 times 2 is 10. 4 times 2 is 8. Yeah. Okay, B. The fruit of the same type must be arranged together. So when you say the fruits of the same type, here we are referring to what? Hello.
3
Watermelon. 2 pineapple. 4 mangoes. Yes? Okay, how many ways to put a watermelon next to each other? 3, 2, 1. How many ways to put a pineapple next to 1? How many ways to put a mango? 4, 3, 2, 1. Now remember the technique I say, you got to tie them together. Tie them together. Tie them together. How many ways to put these 3 blocks in a row now? 3, 2, 1. Remember, this is tie together. There are 3 blocks now. So there are 3, 2, 1 ways to arrange them. So the number of ways is what? 3 factorial ways to arrange a watermelon, 2 factorial ways to arrange a pineapple, 4 factorial ways to arrange a mango, 3 factorial ways to arrange them together. 6, 6, 36, 36, 24, 144, 288. Huh? Factorial means 3 factorial means 3 times 2 times 1. Did I calculate wrongly? 36. 36. Wait, 36, 24. Sorry, I'm wrong already. I counted wrongly. You count for me now. Yeah, 1728. Sorry, babe. 8 different history books and 4 different geography books on the shelf. Calculate the number of different ways to arrange all the books in a row. If the history book and geography book must be arranged alternately. Now, we mentioned to you, alternately means what? History, geography, and so on. Now, I have to start with history first. Why? Because there are more history book than geography book. So I put history, geography, history, geography, history, geography, history, geography, history. So 5 factorial ways of 5, 4, 3, 2, 1 of arranging the history. How about the geography book? Geography is what? 4, 3, 2, 1. So you times 4 factorial. Answer will be 2880. Simple, right? Yeah? Okay, B. All the geography books are kept together. So you put geography, 4 geography book. Now, they didn't say that history book must be together. So we have to do separately. Okay, again, the technique that you need to know is that when you keep all the geography book together, there are how many ways? 4 factorial. So you tie them together as a block. How many blocks do I have now? 6. So 6 factorial, 4 factorial, 2880.
Wait, that's the wrong answer.
Oh, sorry, I wrote wrong. Yeah, thank you. 17280. Sorry, I seen the wrong one. Thank you. Next one. So, now we want to use permutation for R object chosen from N object. Yeah, when you have a condition now. Okay, so now just so you know, two of you who didn't come last lesson, if you have 8 items and I want to arrange 3, how many ways can I do that? We can write like this. Draw 3 boxes. Then this will be like 8, 7, 6. So the number of ways you can write this is 8 times 7 times 6, or you can use 8p3. Now 8p3 means 8 arrange 3. P stands for permutation. It's here. 8 shift multiply 3. The result is 336. You want to do manually 8 times 7 times 6, or you type 8p3 also can. Okay. Now this is without condition, but in this question we have a condition. We want to form a 4-figure odd number from this digit. Now remember, whether number is odd or even, it depends on the last digit. Now what is on your last digit? 1. In order for it to be odd, remember last digit must be odd, right? So 1, 3, 5, and 9. So I have 4 options. Correct? 1, 3, 5, 9. So we write down the number of options here. I like to list out like this because this is a set that represents my possible option. I can choose any one of these 4. Now, and remember, total you have how many? 2, 4, 6, 7. You have 7 digits. I've taken 1 out. So I'm left with how many? 6. This condition must be fulfilled first because it's an what? It's an what? What type of number? Odd number. Right? Last digit must be odd, right? So this one is 6. Take another one out, left with what? 5. Take another one out, left with 4. So the number of ways you can write this as 6 times 5 times 4 times 4. Or you can say 6p3. Now what is the meaning of 6p3? Out of 6, I arrange 3. And then you times with 4p1. What is the meaning of 4p1? Out of 4, I arrange 1. So guys, this is 480. Correct. Betul. We draw 4 boxes. Now, if it's greater than 4,000, you need to start with what? 4, 5, 6, 7, or 9. Now, remember, when you say greater than 4,000, I can start with 4, you know? Because, for example, if I start with 4, followed by 0, followed by 2, followed by 5, isn't this still greater than 4,000? It is what? Yeah? So, there are how many ways here? 5. Now, how many digits do I have? 1, 2, 3, 4, 5, 6, 7. Again, I have 7. I've taken 1 out, left with how many? 6, 5, and 4. So the number of ways you can write 5p1 times 6p3. Yeah.
But you can't put 0 in the last.
Can I? I can start.
Oh yeah, you can.
I can. I just cannot start with 0. Yeah. Can be made from the letters.
Wait, number 14.
Sorry. Oh, sorry. I am too fast and furious. Sorry. Question 14. A 4-digit number is formed by using 4 of the 7 letters. 7 digits. Sorry. No digit can be used more than once in any one number. How many 4-digit number can be formed if the number is even? Okay. So number 1, I draw 4 boxes. 1, 2, 3, 4. Okay. If the number is even, means it must end with what? 4, 6, or 8. Correct or not? 4, 6, 8. This is 3. Yes? Okay. Is there any other condition?
Yeah, if you use the 4 in the back, this 4 in the front.
Okay, because we say we go about part A first. The number must be even, right? So there are 3 options here, right? So we have 7 digits to choose from. I've taken one out. Left with how many? 6, 5, and 4. So the number of ways again is 6p3 times 3p1. So this is 360. Correct? Yes? Okay, B. The number is even and is less than 4,000. Okay, now I have to still, everyone, I still have to fulfill this condition. It's still even, right? Yes, anything? Okay, now it must be what? Less than 4,000. If it's less than 4,000, means I have to start with 1 or 3. Can I start with 4? No. I know some people say, Terry, less than 4,000 I can have 2 digits, but no. The question asks for how many digit number? 4 digit number. 4 digit number, yeah, you must have 4 boxes, right? So, everyone, next, what do? I write down the option. This one has to be what? 2. This one? 3. I have 7 digits. Taken one out here, taken one out here. 5 and 4. So the number of ways is 2 times 5 times 4 times 3. I know some of you want to write 2p1, 5p2, 3p1. Also can answer is 120. Yeah. What I need to do is what? Draw 4 boxes. Okay. It must be greater than 6,000. If it's greater than 6,000, we have to start from what? 6, 7, 8 or 9. 6, 7, 8 or 9. So they are 4. Okay. Now, how many digits do you have in total? 1, 2, 3, 4, 5, 6. If you have 6 digits, I can choose 5 here. Right? I've taken one out, left with 5. Then this is 4, this is 3. So the number of ways is 4 times 5 times 4 times 3. You can write 4 arrange 1, 5 arrange 3. And somebody, you got 600. Understand this, so the last number must be 0, 5. So there are 2 ways here. Okay, at the same time, I need to fulfill this condition 6, 7, 8, 9. So you have 4. This one will be what? 5 and 4. Still 5 and 4. So the number of ways is now 4 times 5 times 4 times 2. Did I make a mistake? Yeah. No, it's not 96 now. I think I made a mistake. Oh, sorry, it's not 5 times 4.
4 is 4 and 3.
Yeah, sorry, man. 4 and 3. I made a mistake. It's 4 and 3, yeah? Because I have 6 digits, I've taken 2 out. 4, 3, 2. So yes, it's 96. Yeah? Okay. Now, let's look at the next one. How many different 4-digit odd number less than 5,000 can be made from this digit if no digit may be repeated? Okay, this one is a bit more difficult. When you say less than 5,000 means you have to start from what? 1, 2, and 4. But at the same time, it must be odd number. Odd number means 1, 5, 7. Now here's the problem. If I start with 1, I need to reduce the number of options by 1. If I start with 2 and 4, it doesn't affect my selection here. Correct? So what I choose in the first digit, it matters. Yeah, it affects the solution. So under this situation, you have to do 2 cases. Case number 1, we start with 1. Case number 2, we start with 2 or 4. Yeah. When you have a situation where I select certain digit, it affects the selection here, or if I select another digit, it does not affect the selection here. We have to do 2 cases. Okay, let's say I start with 1. This will be 1, 5, 7. True or not? but I cannot choose number 1 anymore. So this is only how many ways? 1. How many ways? 2. I cannot choose one anymore. I just want to purposely put here and cross it out so that you know that we have to choose 5 or 7. Now, how many digits do you have in total? 2, 4, 6, 7. So how many left? 5 and 4. So the number of ways will be 1 times 5 times 4 times 2. You can write in permutation form. So this is 40, right? How about the second case? 1, 2, 3, 4. I have to start with 2 or 4. I must end with 1, 5, 7. So how many ways here? 2. How many ways here? 3. This will be 5, 4. So the number of ways is 2 by 5 by 4 by 3. 240, eh? This is 12. 120 lah.
Yes.
120, right?
Yes.
So what's your total?
160.
40 plus 120, 160. You add them out. Okay? Like I say, you draw 1, 2, 3, 4, 5. It must be between 40,000 and 70,000. So you must start with what? 4, 5, 6, 7. Sorry, cannot be 7. Yeah, doesn't include 7. So even number means 2, 4, 6, 8. So there are 4 options here. There are 3 options here. But you see, if I choose 4 and 6, it does affect my selection. So that's why I have to do 2 cases. Case number 1, let me start with what? Start with 5. So you can do the reverse. I know some of you did the other one first. So when I start with 5, how many options do I have here? 2, 4, 6, 8. This is 1. This is 4. This is, guys, total how many digits? 2, 4, 6, 8, right? So this will be 6, 5, 4. So the number is 1 times 6 times 5 times 4 times 4. You can use 6b3 times 4b1. This will give us the D480. Correct? Now, case number 2, we start with 4 or 6. So when we start with 4 or 6, please take note, everybody. This is 4, this is 6, this is 2, 4, 6, 8. This I still have 3. If I've taken number 6 times 3, my total is 41,200. Okay, let me switch on the angle. Okay. Sounds like China. No, anyway. Now let's look at the next one. Now the 4-letter code can be made from the letters of the word complex. Okay, so the code ends with a vowel. Vowel means A, E, I, O, U. So I need to make 4-letter code. 1, 2, 3, 4, and it must end with a vowel. Means it ends with O or E. So there are 2 ways here. Now the word complex has how many letters? 7, right? So I've taken 1 out, left with 6. Taken 1 out, left with 5 and 4. So the number of ways is 6b3 times 2b1. 240, yeah. Let me see, 30, yeah, 240. Okay. So how about the next one? The vowels and consonants are arranged alternately. Now please take note. How many vowels do you have? 2. The vowels are O and E. The consonants are C, M, P, L, X. Now, when we say arrange alternately, right? In this case, you have how many letters that you need to form? 4, right? So when you have 4 letters, right? Meaning I can have vowel, consonant, or consonant, vowel, consonant, vowel. In this case, I must have exactly 2 vowel and exactly 2 consonant. Otherwise, you cannot arrange alternately. Right? You can have 3 vowels and 1 consonant, or you cannot have 3 consonant, 1 vowel. True or not? Even if it's even number, you must have equal number of consonant and vowel, right? So now, let's say I start with a vowel. How many ways to put a vowel? 2 and 1. O, E, E, O, 2. How about consonant? Now, consonant is interesting because we have 5 others, right? 5 consonant, right? So what are here? 5 and reduced by 1? 4. So the number of ways you can write like this are 2 times 5 times 1 times 4. Now I need to times 2. Everybody, why must I times 2? I can switch them. So it's 10, 80. Yeah. Yeah, from the word abdomen. I want to find a 5-letter code. The code must begin with letter N, A, yeah? Ends with letter N. So how many ways here? 1, 1. Hey guys, I got 7 letters. I've taken one out, left with what? 5, 4, 3, right? So we can write 1 times 5 be 3 times 1, 60. Okay? The second, it begins with 2 vowels, followed by 3 consonants. So here the order is important. Vowels must come first, consonant must come later. How many vowels do we have? Vowels that I have is A, O, E. So this is 3 and 2, correct? Consonant that I have will be what? B, D, M, N. So it's 4, 3, 2. So the number of ways will be 3B2 times 4B3. Answer? 144. Okay? How many ways we can arrange the letters in the word education? Education is unique because it contains all the vowels in our alphabet system. Yeah, all A, I, O, U, right? So it must begin with a consonant. Guys, your consonant will be what? D, U, D, C, sorry. D, C. Consonants are D, C, T, N, right? The vowels must be E, U, A, I, O. All the E, I, O, U lah. So I need to arrange how many? 6. 4, 5, 6. It must begin with a consonant 4, right? The rest will be what? 8, 7, 6, 5, 4. Because you have 9 cards. Yeah. So number of ways will be 4 by. If you're lazy, just write 4 arrange 1, 8 arrange 5. Somebody. Who can help me? Anybody? 2 excluded. Okay, there are but I have 1, 2, 3. Put letter E here. 6. Okay. So the number of ways is 6 arrange 1. I have 6 empty spaces. I put 1 letter E. Yeah. So let's say I put letter E here already. Letter O must be excluded. Throw away letter O. How many letters left? Come on. 9. I included E. Throw away the O. I'm left with 6. Yeah. So is 6 arrange remaining 5? Oh, sorry. Not 6. 7. Because they're 9. 9. Take out. Put the E there. Throw away the O. Left with 7. Sorry. Somebody? 1, 5, 1, 2, 0. But okay, guys, maybe sometimes I should make it a little bit difficult. If, okay, I just add in this. If letter E and O must be included, then how does it work? If letter E and O must be included, so you got to think. I have 6 empty spaces. I arrange 2 of them. Yeah, is 6 empty spaces arranged to the remaining 7 I arrange 5. Yeah, I hope you understand the difference. Because I don't want to give you such a simple one, then my tutorial is a bit harder. Because I think my tutorial have to arrange 2. If why is it 4? Because you're arranging 6. Right? Oh, okay, for this one, yeah. For this one, yes. Thank you. Thank you very much. And your answer? Anybody? 25200. Yeah, I'm just telling you the difference between B and C. I could call this C if you like. Yeah. Letter E and O must be included. Let me explain the first part. Marcus arranged 6 of the cards, 3 of the cards in a row. So I draw 1, 2, 3. Yeah. Okay. So letter P is placed in the middle. How many ways to put the P in the middle? 1 way. So the rest I have 5 and 4. So number of ways you can write 5 by 1 by 4, which is 20. Okay, letter P must be included. So I draw 1, 2, 3. How many ways to include letter T? 3 arrange 1. Let's say I put letter T here. How many left? How many left? Remaining 5, I arrange 2. that will give us 60. Okay or not?